Hello everyone, good day my subscribers. My name is Joseph Ocheme, the content creator of Fuelless Hub. Thanks for people that have been subscribing. Thanks for those that have been supporting me. Thanks for those who have contributed immensely to this project, to this work, and to everything. So right here, I'm going to show you a video of a self-sustaining system that I made that was self-powered, was giving out approximately 10 watts of power continuously. So you don't need any power from any external source. So here is a demonstration. Now this video is a 40 minutes video, so please take your time, watch the video, because I'm going to go step by step on how I tested the whole machine, the whole device, how I tested it. So it's a 40 minutes. So in between the videos, there are pauses in the video, there are breakage in the video, because I did the video for 10 hours. So all the whole 10 hours I have to wait for some time because I can't put the camera out 10 hours. So the video, which I actually harnessed from all the testing and everything, was 40 minutes. So please watch the video, don't skip the video, watch step by step, don't skip the video. So it will give you a clear demonstration. Free energy is possible, free energy is real, depending on your procedure, technologies, and the ways in which you go about it. So here is a device that outputs 10 watts continually. There is also a higher version, an advanced version, that also gives higher and differently, but this is just a little test for you to see and to prove that free energy actually exists. My name remains Joseph Ocheme, the content creator of Fuelless Hub channel. Thank you so much. Watch the video. Thank you.
Here is just a car battery right here. Car battery. A bike battery powering these whole systems. So, and it is charging. So this battery right here is powering this whole system, while this same battery is also charging back. As you can see, the voltage has risen. I've kept it here for a couple of times. It has risen from 13.80 something, so it's now on 9 something. Why driving this socket like this? So let's wait here and see how the voltage rise. I'm gonna spend some minutes here to show you how it works. This thing is consuming 100 milliamps. 100 milliamps. That is what it's consuming to operate. 100 milliamps. 100 milliamps. You can see the voltage is rising. So this is just like a self-powered system, continuously rolling. So you can decide to attach a fan here, a fan that blows endlessly. So this is the battery, and it is actually receiving a charge. The voltage is climbing up little by little while powering this whole circuit. Let's wait till the voltage rise to around, let's say, 14 volts. Everything is spinning, self-sustaining. The coils are wound in a different format and in a different form. Everything is spinning. So we're going to wait here till the voltage reaches 14 points. As I told you, this socket is what is powering all this, and what is consuming from here is around 100 milliamps. So when you times 100 milliamps, that is 0.1 times 13 volts. This is a 12 volt battery, but times it by 13, you will know how many watts is giving out. How many watts is entering into all this to function, all this, and it is equally charging. You can see it has entered 14 volts. It has entered 14 volts. It is entering 14 volts. Let's just wait to enter 14.1 so that it will be stable on 14. shocked and amazed at this wonderful performance. So I'm just doing a couple of testing on this. The voltage is climbing up. Let me remove it. And I'll put it back again. So everything is powering from this socket. It's powering. So here is just like a free energy. This is a free rotational spinning. You can put anything there like a fan or anything to power your system. And there is also extra voltage coming out of these two sockets also that we can also tap and use, but we have decided not to use this. Just seeing a self-sustaining and a self-powered system. You can see its voltage is climbing up. So on the next stage, we are going to collect power from this. We're going to collect power from this battery so as to know what we are powering for a longer period of time that will be self-sustaining. Thank you very much. God bless. The milliamps is consuming from this battery while charging the battery. I'm sorry. 0.09. Let us say a 0.1. Let us say 0.1. So powering all these systems, and white is equally charging. You see, I showed you the last voltage before I ended the video. So as it is now, it's still charging. So here's the milliamps. So let me connect it back. So I can show you the voltage once more again. So it is connected. Let me put it to voltage. Got it. 14.6. 14.06, 14.07. It's actually climbing higher. So here's the voltage. The voltage keeps increasing. I'm charging the battery of this phone, and from my calculation it was consuming 0. That is the milliamps going into this phone charger is approximately 4 point something watts, because it actually gives the milliamps that enters this battery is 0.28. so let's say approximately 0.28. then we'll times it times 14 point something, so approximately roughly 5 watts. Let's just say 4.5 watts. So this thing is consuming 4.5 watts to charge the battery. So the battery is charging off from this socket, and this is the voltage. So we are doing a load test. As you can see, it's still spinning. So we are examining a load test. This is a self-powered system charging a battery approximately 4.5 watts, and the battery is charging itself via this system. So it's a self-powered system like this, charging a mobile phone. So out of this, we can harness, you can put a fan here that can blow, and we can also use a 4.5 watt of energy continuously, non-stop. So you can see the battery is still struggling between 7.6, 7.5. It's struggling because I am extracting power now out of this. So, but if you are not charging your phone, if you disconnect it, the battery keeps charging. So anywhere you go, you can go anywhere with this device. Even though your phone is low, you can charge your phone, do everything, because this phone is charging from this battery, because there is a socket here that converts 12 volts to 5 volts that charges a normal mobile phone. So the charging rate for this phone is 4.5. So I'm not sure whether it can work for a bigger Android phone, because a bigger Android phone consumes a lot of watts, like 30 watts. But as long as our testing remain right here, we are consuming 4.5 watts 4.5 watts from this socket. So this is the voltage of the battery right here. It's 14.84. So right here I'm removing the battery is charging, as you can see. It's charging from this battery. So let me show you the percentage. Actually, come in. As you can see, the battery has charged a little. It's not this bar that was on it before, but I didn't show you people earlier. Come in. So the battery is charging. So from this, so I'm removing 5 watts from this battery. 5 watts to charge this battery. So that's what I'm using, and everything is still spinning. The battery of this battery, the voltage is still increasing, meaning it's charging even while charging this mobile phone. And there is a rotation here. There's an extra energy in this rotation, and everything is running self-sustaining, charging the battery, rotating, and charging this battery. There is no form of any input from anywhere. Hello. So I've been charging the battery now for over 20 minutes. I've been charging it for over 20 minutes now. So the battery keeps charging. The battery keeps charging on this, and this is the voltage right here now, between 8.9 to 14.91. Let's just say 14.89. So all from this battery. So this battery is still charging itself from this particular system right here. It's still charging itself, and we are using approximately 4.5 watts. Though I'm going to do other tests, like to extract like 7 watts, 10 watts while calculating, but right now we are sure of approximately 5 watts of energy coming out of this design, charging the battery. A self-sustaining system. You can see the battery 14.91. The previous video which I posted was like 14.7, 14.8 or so. So yeah, you can see it's still charging, and energy is still going to the battery. So we are having a genuine power now, a genuine output of 5 watts. Now let me try and show you guys from the amp meter. Let me show you now from the amp meter what is actually entering. You know, I told you guys, I told you it was 5 watts. So let's do a confirmation for that. So I remove my clamp from here, and I'm going to do it fast because I don't want any a breakage in this. So let me change it to amps. Then I'll put one of this one here. Oh, sorry, I'll have to remove this. I'll put one of this one here. like this. Then let me use my finger. I want to use my finger now to cross it with the others, so you can see the charging rates. I just mistakenly bridge the battery now, so I don't know what might be wrong in the system. Maybe the voltage would have gone down a little, so but that's not our problem. We are assured of a secure charge entering this battery. So we want to check the amps going in, that is the charging amps, but we want to take it off from this socket. We've set our clamp meter to 10 amps, so let me do it quickly. Excuse me, let me change it. So as you can see, I've connected it right here. So this is what it is giving out. Sorry, 0.25 that is the amps. 0.25, so that is the milliamps. That is 250 milliamps charging this battery. So let's pause it so that I will show you the voltage on this battery. So once we times it together, we will know the watts it will get. So let me put the charging back. So our video is still on. Let me take it back to so here's our voltage, 14.94. so times the amps, 2.5 times 14.9, let us say 14.95. Once we times it together, let's use our charging phone to do the test. Everything is still working normal. It's still charging this battery. Now you see that the battery has risen to 14.94, meaning we can still get a lot of watts out of this. So again, the battery have been charging for a couple of little time. As you can see, look at the voltage now of the battery. Just for some minutes after I posted that video, just for some minutes, as you can see, it's still charging this battery, self-sustaining. It's even overcharging the battery. So there's a lot of energy of pulses also entering inside this battery, and it's still bringing out. So we have opportunity to take more watt. As you can see, the battery is still charging. So you can see it's still charging. So this can be kept anywhere. You can charge your mobile phones, do anything you want to do. Everything is self-sustaining. There's no power input from anywhere, from any source. No power. This is just what is powering the system. Conveniently. So this can be taken anywhere in the world. Still charging the battery from this small phone. Watts can still be gotten from here, because as you can see, the battery is giving excess charge. From my videos, you will be noticing the battery keep increasing. Even as I'm doing the video, the battery keeps increasing while charging this phone. So that is how it has been. I would have put a wall clock here, but this one just take a couple of, let's say 10 to 15 minutes or so. Let's say 10 minutes, and look at the battery fully charged. And this system can be here for months, and you are extracting power from here for months, as long as everything is set accurately. This is again, I want to add this LED bulb on this battery, so we can have a continuous power. So let's check the milliamps. This is a 12 volts
but a bulb, 12-volt bulb. So let's check how many milliamps is consuming. So I've set my clamp meter, I've set my multimeter to 10 amps. So one is already set to here. So I'll put the negative. We just want to check how many milliamps this thing is consuming before we plug it to the battery, so we can do another test. And this particular bulb bright so well, so let's put it to see. As you can see, it is shining, and this is what it is consuming: 0.15. Come in, let me set it very well. As you can see, the bulb is shining. 0.15. You can see. Sorry. So, and the bulb is very, very shiny. So we want to add this bulb to this particular battery, so we can extract more power, because it's a self-sustain. We want to extract more power from it. So let's check the voltage of our battery again, because our battery is overcharging. Let me not say it's overcharging, it's actually giving out from this. The battery is really getting high, and that is our method. Sorry. So our battery is 15.7, and we are still withdrawing power from it. So let us connect this. We want to have a constant light on it. So let's fix it here. I'll fix the other one here also. Sorry. As you can see, the bulb is on now. So look at our voltage. Our voltage has reduced a little to 15.05, 15.03, 15.02. So we are still maintaining our stand. So let's leave this for a couple of minutes. Let me leave this for a couple of minutes to come back, so that I can see the watts. Right now my clock says 9:36. There's no wall clock here. Now that I've showed you guys. Yeah, we can use the phone. This is 9:36 p.m. Nigerian time. You can see the date. From here. So 9:36, 9:37. So let's leave it to see what will come after, to get whether the voltage will increase or it will get low. But we are extracting. Now we already know that this thing is consuming 1.0. That is, let's say, a 150 milliamps. This one is consuming 250 milliamps on this. So, and this is our battery voltage right now. So let's wait. As you can see, this is the time, 9:37. Still 9:37. So thank you. So right here, this is the battery voltage. Right here, this is the battery voltage, 15.05. So this battery just showed me just now battery full. You know, the time that we were before was 9:37, also 9:38 on it. Now this battery is fully charged. Now we have been charging this battery over 2 hours. It was half percent, because I've been doing this video since 7:02. That's when this system has been working like this. 702, and the battery then was 13 point something. So right here the battery is fully charged. So maybe I'm thinking of a way of connecting another load, but right now this might be the end of our video right now. But be rest assured that this device can emit 5 watts continuously. 5 watts. Maybe in my later videos I'm going to test this system again. I'm going to test all these systems again with probably a higher watt. So maybe I might stop the video now, 9:43, but I started this video 7:02. So this is like a 2-hour test. I don't know, 7, 8, 9, yeah, about 2 hours plus or so. Yeah, from 7:02 to now. So just believe me, that's when I've started. So I've been monitoring the progress of all this system. As you can see, it's charging. So I'm only powering this bulb right now, and this one is filled already. Let me show you guys when I put the charger. Look at it, charge complete. I don't know whether you guys can see it. I'm a one-hand camera. Look at it, charge complete. So just charge just now, and the battery is really going up now because there's nothing coming out of it again. So that is it. In my later video I'm going to put some certain stuffs in order. Thank you. You know, our battery was fully charged, so now I'm powering this small Wi-Fi. This is a small Wi-Fi, and this is what it is consuming: 1.15 amps. That is 1 amp. So let's give it a shot to see how the charging rates to be. This is risky, as you can see. Let me show you the time. This is 9:48. So 1.6. So let me put this together. Let's see how what it will take us. So almost triple, even more than. Thank you. And see, this is the time now, 9:49. So I'm charging this Wi-Fi with 1.16 amps, and here I've put the clamp meter. Here's the clamp meter voltage, 14.89, 14.88 to 14.89. So everything is still self-powered. So this Wi-Fi actually consumes a lot. So let's give it a try. So this is a 12 volts charger. So let's do a calculation. Which we did the other time. So the amps was 1.16. So we times it. Look at the voltage. Let us say 14.9, because that's what is entering inside the system. So actually that's the charge of the battery. As you can see it's even going higher, and the Wi-Fi is charging. As you can see, consuming 1.16 amps. So let's times it times the voltage. Let's just say 14.89 volts. So 14.89 equal to 17 watts. So we are pulling 17 watts. This Wi-Fi is pulling 17 watts from the system, and the system is still charging. What the heck? 17 watts. I'm pulling 17 watts right here. 17 watts, and it's still charging, still fluctuating between 14.9 like that. So let's check the time. 17 watts, 9:51. Hello, so we are back again. So this is our Wi-Fi. Our Wi-Fi is still charging. Right here, and this is the time. 10:27. So 10:27, that is the time, 10:27 p.m. So everything is still running smoothly, and this is the voltage of the battery, 14.94. It's just now it climbed to 40.95. So if you can check it with the voltage of the last video, and this is 10:27. You can check the other video, because this is a series of videos. This is a continuous test. There is no breakage, so I've been up and awake. So we remember the watts this thing is consuming. 17 watts is charging right here. Once it is fully charged, this light here we continually to show. So we are extracting 17 watts. I told you it was a risky adventure, but let's test it. I told you we can draw more out of this. So this thing has been running for quite a long time now. You can see 10, 20, 10, 28. I'm doing this video on the 30th of March 2023. That's when I'm doing it. So as you can see, our battery is still charging, 14.94. So, and this system is still running. You can run your fan from here. You can attach a fan or whatever constructed. So this thing is still running, and the battery is self-charging. I'm using only this one battery, and we are extracting 17 watts. Let's just say approximately, let's give it a factor, and let's just say 15 watts. So we have a 15 watts of power right here that is continuous, charging and doing everything. As time goes on, there might be further experiments which will be undergone on this. So here is as it is. I've been powering it now for a long time. I told you I started this video by 7:02 or so. So yeah, and this is 10:29. You can see the battery still charging, powering our Wi-Fi through this socket right here. As you can see, everything is up and running. So let me still wait to see how the voltage, maybe the voltage will still rise, but this thing is self-powered. You can just charge your mobile phones. So self running. So this is another video. As you can see, this is the time, 2:16 a.m. So as you can see, the component is still running effectively, 15.17 volts. This battery is 98%, just remaining 2% to become full. So I've been running this thing since 7:02. Everything without any source of any power from anywhere. So I've been doing it. So from 7 p.m. 8, 9, 10, 11, 12, 1, 2. So this is around 7 hours. I've been collecting what. The first one was I use this mobile phone. Second one was this thing was actually charged full. Then I charged this one. Then I charged this particular stuff right here with it. So that is it. Let's see, 99%. So approximately this phone will soon be filled up with this device, and this is the voltage of the battery. So there is a genuine power being extracted from this, and I'm still going to find another load to power with it, so that we won't overcharge the battery, because there is no circuit to regulate the charge in the battery for now. That's what we're going to build that later. This is just a test and a prototype. So this is the last part of the video. I've disconnected my phone right here, as you can see, but I want to plug in my phone right here now.
So right now I'm going to stop this video now. So this is the time. There is 2:30 a.m. I want to stop this video because I want to go and sleep right now. So this is what I want to do. Instead of this battery right here, because this battery is charging and I can't leave it for now. So this my other battery that is here. This is a Genius battery, a 220 amps, 230 amps. So I will use this system to charge it up. So but I'm going to check the voltage, then I'll go and sleep till when I wake up. I will check the results from there. So I'm connecting it to this battery so that this battery will rest. Then while I from this socket power that other battery. So here is I've connected the battery now. So this is the system. I've connected the positive and the negative down to the battery. This is positive. So down here. So this is the voltage, 14.76. But this voltage sometimes is different from the voltage on the inverter. So let's check the voltage on the inverter. I want to check the voltage on the inverter so that once I wake up, I will know at least what I've added to the inverter. I don't know why the inverter is giving different volts, but let's 11.6. So once we wake up, we'll check it. So it is this same inverter that is powering my whole house right here. The same inverter that is powering my bulb, my fan. So all these things will be left on. So this is the charger controller of my battery. So it's night, so nothing is happening to the battery. So once I wake up early in the morning, we'll come and check what is happening to our battery, to our system that is charging. So let's check whether it will add. So as you can see, I'm powering. This is a 5 watt bulb. So I will leave them on, and there's a fan inside my room blowing right now. So but everything will be on down. And also this inverter also consumes. It's a big inverter that consumes close to 16 to 17 watts when there's no load. When there's no load on the inverter, it consumes 16 watts. So what will happen is that I'll off all the bulbs in this house. It will be only fan. There's a fan inside my room. There'll be only fan that will be blowing. So this is the system. So let's see how it will take. There is also a bulb in my room, in my other living room. So everything will be on down. The bulb in my room will be on, the 5 watt bulb, and a 15 watts fan is inside my room right now. I have, because of some privacies, I can't show you inside, but believe what I tell you. So I'm going to off all the lights right here. I'm going to off all the lights while the system keep charging the battery. So hello, good morning. So this is in the morning right here. This is 5:47 a.m. I just woke up to check the system. So here's the voltage. Here's the voltage now, and we have been powering a load. We're powering a fan, which is in my room. The fan is 15 watts, and the bulb is 5 watts. So that's what has been on for a longer period of time in my room. So let's see the voltage of the inverter. The voltage of the inverter is still 11.6, meaning there is no drop in the current from the inverter. the current was steady while powering a 20-watt load. While powering a 20-watt load, so the voltage is constant. But on the multimeter here, the voltage have risen. So it's just now just on these lights. So there's only one bulb that is on. But in my room right here, the fan is on. So man, this is a free energy, self-sustaining, self-running. In our next video, I'll test it in other forms. Thank you.